Good morning. Today we are working on CO18. I can find the greatest common factor of a set of numbers. So we're working with those factors that we were talking about yesterday. Now we're working with the greatest common factor. So we're comparing factors from different numbers. So a common factor is a whole number that is a factor of two or more non-zero whole numbers. The example of this, if we look at 8 and 12, their common factors are 1, 2, and 4. If we were to list out all the factors of 8 and 12, we'd have 1, 2, 4, 8. 12 would have 1, 2, 3, 4, 6, and 12. We want to look at the ones that they share. They're common factors. So they share the 1, they share a 2, and they share the 4. So it's numbers that they have in common. Adrian, pay attention. The greatest common factor is the greatest whole number that is a factor of two or more non-zero numbers. So if we look back up at that 8 and 12, our greatest common factor is that biggest number that they share. So that would have been 4. If we looked at all the factors for 18 and 27, their greatest common factor that they share is 9. They also share 3, but that's not their greatest number. We want the greatest common factor. Relatively prime. We know a prime number is a number that can't be broken down anymore. A relatively prime is when two or more non-zero whole numbers whose greatest common factor is only 1. So they're not prime numbers themselves, but the only factor that they share is a 1. So we call them relatively prime. So if we looked at 9 and 16, we know 9 has the 1, the 9, and 3. 16 has the 1, the 2, the 4, the 8, and the 16. The only factors they share are 1. So we call it relatively prime because every number shares a 1. So relatively prime means they don't share any bigger factors. So making a list to find the greatest common factor. Find the greatest common factor of 16 and 28. So we're going to make that list like I was making up here. We want to put our numbers in order. So if we look at 16, we know a 1 can go into it. We know a 2 can go into it. 3 cannot. 4 can. 5 cannot. 6 cannot. 7 cannot. 8 can. No 9, no 10. So we know that 4 times 4 is 16, 8 times 2 is 16, 1 times 16 is 16. So now we look at 28. We always know there's that 1. So even number, so 2. 3 cannot, 4 can, no 5, no 6, 7. 7 times 4. 8 cannot, 9 cannot, 10 cannot. So I know 4 times 7, 2 times what? 2 times 14, and then 1 times 28. I'm putting them in order so it'll be easy for me to match up my numbers. I see that we share the 1, the 2, and the 4. So my greatest common factor would be 4, the biggest factor that they share. So now let's look at it with a word problem. So let me move the page up. Looking at it when you're just given the two numbers, it makes sense. Okay, I've got my two numbers, I find my factors, boom, done. But now I have a word problem, and sometimes those word problems can be a little overwhelming. So let's look at what it's telling us. It says, what is the greatest number of ensembles that can be formed with 32 violinists, 40 violists, and 16 cellists? So what they're wanting to know is the greatest common factor between those three numbers. So you need to break down those groups to make even sets. So we want those common factors to show if we were to break down our groups into smaller groups, what can we evenly distribute? So they all have the same number of violinists, same number of violists, and the same number of cellists. So we're going to find their common factors and find which one is the greatest one. So when you're given that word problem, you're just working out your greatest common factors. So on your papers, start writing out what the common factors are. We know they all start with a 1. That was easy. And they're all even numbers, so they all have a 2. Now it gets a little more challenging. So I'm going to go one number at a time. So I'm going to look at 32. Can a 3 go into 32? No, 3 doesn't go into it. Can a 4 go into 32? Yes. Can a 5? No. 6? No. 7? No. 8? Yes, and 8 can go into 32. 9? No. 10? No. So we know 8 times 4 is 32. 2 times 16 is 32. And 1 times 32. Now I had some friends earlier who said, well, I know 2 can go into 32, but I don't know what to multiply it by. We know dividing is the opposite of multiplying. So if we're not sure what the factor buddy is, we know it's an even number, 2 can go into it, go over and divide it. 2 goes into 3 once. So it's 3 minus 2 is 1. Bring down our 2. 2 goes into 12, 6. 6 times 12 is 12. So it goes in there evenly. So 2 times 6 equals 32. So if you're not sure what the factor buddy is, because it's a big number, you know the smaller number goes into it, you need to find that big number, go back over and you can do division. Do the opposite to find it. So now let's look at 40. 3 cannot go into 40. 4 can. 5 can. No 6. No 7. 8 can. We know 8 times 5 is 40. 9 cannot. 10 can. 10 times 4 is 40. Now I need to look, what is that? 2 times what? Priya? 20, yes. And then we know 1 times 40. So now for our 16, we know the 1 and the 2, no 3, 4, no 5, no 6, no 7, 8. So we know 4 times 4, 8 times 2, no 9, no 10. So it would be 1 times 16. So I have my list. So now I need to find the greatest number. So first thing I'm going to do is look at all my common factors. So they share 1s, they share 2s, they share the 4s, they share an 8. No 16 here, no 32s, that's it. So now that I've looked at all of my common factors, I'm going to look at the greatest one. So the biggest number going out is my 8. So what is the greatest number of ensembles? The answer is 8 ensembles. So you work with those common factors and look to see what's the greatest common factor. They're not always going to line up. This one kind of snaked around because there was a 5 in for this one. Still a greatest common factor because each one had an 8 listed. Now we're going to use that prime factorization from yesterday. Another way to find the greatest common factor is of 2 or more numbers is to use prime factorization. So one way to find the greatest common factor is the GCF, is to do your list. Another way is to do the prime factorization. So if we have 180, that would be 2 times 90. 2 is a prime. 90 is 2 times 45. 2's are prime. 45 is the 5 and the 9. 2's are prime. 5 is prime. 9 can be broken into 3 and a 3. So I have 126 divided by 2 would be 63. 2 is prime. 6 is 9 and 7. 2 is prime. 9 is 3 and 3. 7 is prime. So what I'm going to look at is to see which primes do we have in common. And I see we have 2 times 2 times 3, 2 times 3 times 2, oops, 1, 2, 1, 2 here. 2 3's, 2 3's. So what we have in common is 2 times 3 times 3. To find the greatest common factor, I do the math. 2 times 3 times 3, 2 times 3 times 3, 2 times 3 is 6. 6 times 3 is 18. So our greatest common factor is 18. So you don't have to make the whole list of all factors. You can break it down to all of their primes, multiply the primes together. They share 2 times 3 times 3, so that means they share an 18. Well,
Couldn't you do 2 times 3 to the second power?
yeah. You could write it as 2 times 3 to the second power. So we know 3 to the second power is 9. So we know it's 2 times 9. Both ways definitely work. It's just looking at it differently. Nick?
Why don't you use the 7?
Because this one doesn't have a 7. They don't share the 7.
Oh, okay.
You're only looking at the ones that they share in common. Great question. So we're only doing the primes they share in common. There's only 1, 2 here, so we can only use 1, 2 from over here. And our last example. Identifying relatively prime numbers. So, 13 and 24. We need to find out if it's relatively prime. Do they share numbers that are bigger? Do they share factors that are bigger than 1? So our factors for 13 are 1 and 13. Our factors for 24 are 2. Well, you know what? Let's do it this way. Let's write them out. 13 and 24. 13 is 1 and 13. 24 is 1, 2, 3, 4, 6, 8, 12, and 24. The only factor they share is the 1. So it is relatively prime. Tristan.
So 1 isn't the only factor they share?
What other factors do they share?
3.
This is a 13, hon.
Oh.
It's not a 3.
Well, we're in the flip till we get to the 3.
Okay. So then let's look at 38 and 48. They share 1. They're both even, so they share 2. Do I have to keep going?
No.
Why not?
Prime numbers. Oh, wait.
Because I can see they share more than just a 1. So it is not relatively prime. Because they both share 2. I don't care about any more. That's all I need to know. They share more than a 1. So I can stop right there and say they are not relatively prime. Our assignment for today is page 43 and 44. We're going to say goodbye to our friends at home and hope you have a good day.